If the radius of a sphere is increasing at the rate of 4 inches per minute at the instant the sphere has a volume of 36 pi inches cubed, find the rate at which the A, volume changes, B, surface area changes. Let's write down the information we are given here. We have the rate at which the radius is changing. That would be r prime or dr dt. And it's increasing, therefore it's a positive 4 in units of inches over time in minutes. And we also have the volume given to us. The volume is 36 pi inches cubed. For part A, we want to find the rate at which the volume changes. We have the rate at which the radius changes, so we need to relate the volume to the radius. The volume of a sphere is 4/3 pi r cubed. So there's the related variables equation. To find the related rates, we will need to take the time derivative of both sides, indicated by a prime on both sides. Now, every variable is implicit with time, so when we take the derivative, we will get a prime of the variable for every variable. On the left side, the derivative of v is 1, but then times v prime. On the right side, we have a power rule. The 4/3 pi is all a constant, so we bring the 3 down. So we have 4/3 pi, and then times a 3. Subtract 1 from the power, but then we multiply by the derivative of the inside to complete the chain rule, and that'll give us an r prime. Every variable will get a prime due to the chain rule and implicit derivative on time. The 3 and the 1/3 in the 4/3 will be able to cancel. One's in the numerator and one is in the denominator. So we have v prime equals to 4 pi r squared r prime. We can plug numbers in here. We have an r prime. We're trying to find v prime, but we do not actually have an r. We were given a v, a volume, but we weren't given a radius r. However, the two are related to each other by our related variables equation, so we will need to solve for the radius r. Let's work that out down here. We have the volume equals to 4/3 pi r cubed. Therefore, 36 pi equals 4/3 pi r cubed. We can cancel the pi's out on both sides. And now we can multiply both sides by 3. So we'll have 3 times 36 and divide both sides by 4. So we have it solved at least for r cubed. Now the 4 and the 36 can reduce before multiplying the 3 times the 36, just to keep the number smaller. 4 divides into 36 9 times, so that'll leave us with a 9. And so we're left with 27 equals r cubed. And that means r is going to be the cubed root of 27, and the cubed root of 27 comes out to a 3. Radius will be measured in units of length, and in this problem our length is in inches. So the radius is 3 inches. We now have the radius, and that can plug in up here. So v prime will equal to 4 pi times 3 squared times the r prime given to us, which was a positive 4. And v prime will equal to 4 pi times 3 squared, which is a 9, times a 4. So we have v prime coming out to 4 times a 9 is a 36, times another 4 will come out to 144 pi. So v prime, or dv dt, is 144 pi, and its units of volume, which is the cube of the length unit, we're in inches here, over time, which is in minutes here, so inches cubed per minute. Came out to a positive number, so the volume apparently is increasing here. For part B, we want to determine how the surface area changes. We have the rate for the radius given to us, we just found the rate for the volume, so we can relate the surface area to either one of those two. For the related variables equation, it'll be easier to relate it to the radius because we do have a simple surface area equation. The surface area of a sphere is 4 pi r squared, so it's related in a simple fashion to the radius. We can now take the time derivative of both sides of the related variables equation, indicated by a prime on both sides. On the left side, the derivative of s is 1, but then times s prime to complete the chain rule. And on the right, we bring the power down, multiply it with the 4 pi, so that'll give us 8 pi, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. That'll give us an r prime. Every variable will get a prime due to the chain rule. We can now plug our numbers in here. S prime will equal to 8 pi. We have a radius of 3. And we have an r prime of 4. So s prime comes out to 8 times 3 is a 24, times a 4 is a 96 pi. So s prime, or ds dt, is 96 pi, and it'll have units of surface area. Area is always measured in length squared. Our length in this problem is inches, so this will be inches squared over time, and our time in this problem is measured in minutes, so it'll be inches squared per minute.